Hello students, welcome to the session of Mechanical System Design course. So Unit 1 is based on the optimum design. So in optimum design we will see the objectives of the optimum design, then optimum design, what is this concept, then design for manufacturing, assembly and safety. So what is optimum design? So optimum design is the process of selecting the best possible design satisfying certain criteria among many feasible design or adequate designs. Now if you are designing any particular product or the component that will be useful for particular machine, you can take an example like shaft. If you want to design a shaft, then what are the possible designs are there, okay? So out of that, what is the most significant useful design is nothing but an optimum design. So design of complex system requires large calculations, often repetitively for various combinations of design variables. The computer can perform exceedingly complex calculation and process the large data efficiently. So that was the concept. This is the definition, like it is a challenge for a designer to design an efficient as well as cost-effective system without compromising their integrity. This task is facilitated by the optimum design. So we need to design particular product or the component such that the cost should be there, the cost should be a minimum, but will not compromise with the performance of that particular product. So an optimum design means the best or most suitable of all the feasible conceptual designs. So what are the conceptual designs? Suppose you want to manufacture a particular product or design. So there are many ways or the possible solutions will be there, but out of which one solution will be an optimum solution. So what is adequate design? Is the design which fulfills the main functional requirement of the component. So adequate design is a functional requirement of the design. Optimum design is exclusive of adequate design. For a component there can be several adequate design, but there is only one optimum design, because out of these solutions only one solution will be a feasible one, and that can be useful. So design parameters. So what are the design parameters are there? So design parameters are classified among three categories. First one is functional requirement parameter, material parameter and geometric parameter. So what is this functional parameter? So name itself said that it's related to the functions of the particular product. So it's a condition imposed by the end application of the product. So what is the use of that product? Suppose we want to manufacture a gear. So how the power will be, how much power we want to transfer. So that is a functional requirement. Then for example you can say the gear repair, okay. Then second is material parameter. So it describes the material with values independent of the functional requirement of the geometry. So geometry is not related to the material parameter. So what are the material parameter? Like density is there, modulus of elasticity is there, modulus of rigidity, Young's modulus, like the examples. Then what is geometrical parameter? So parameters which define the limit of geometry or the mechanical component. It's an independent of the functional requirement parameter. So what are the parameters are there? That is an geometrical parameters. Okay. Now classification we have seen. So design parameters in the functional requirement parameter. This we already seen. It's a desirable functional requirement parameter, useful for the mechanical elements to perform satisfactory its functions. like tensile strength, power transmission capacity, storage capacity, bending resistance. So desirable effects are the best when they are maximum in values. Undesirable parameters, what are these? So these are which are detrimental for its functional requirement, and they are the best when they have minimum in values. Like weight of the component, so weight of the component should be there, but it should be a minimum one. Cost of the component should be a minimum one. So these are the cost, we can say undesirable parameters are there. Now equation of the helical spring, like F functional parameter 1 by 8 into rho, it's a functional requirement parameter. G is the material parameter, and the geometry, that is in d raised to 4 upon d cube is in geometrical parameters. So classification of design parameters are in three types: specified parameters, limited parameters, and unspecified and unlimited parameters. So what are these specified parameters? So specified parameters for which specific values are given. So for example, here given this power is given 50 kilowatt. It's given in the numerical, suppose. So it is a specific parameter. Now what are the limit? Limit means from this particular to this point. This is a limit parameter. Like example, diameter is given in between 20 to 40 millimeters. So D is a limited parameter. Then unspecified and unlimited parameters, these are neither specified nor the limited parameters. Okay, so range is not given, and even there the values are also not given, specified. So it is an unspecified and unlimited parameters. Now adequate design and optimum design. We already seen the optimum design. What is adequate design? It's a selection of material and the values for independent geometrical parameters for mechanical elements, such as mechanical elements satisfied its functional requirements, and undesirable effects are kept in tolerable limit. For example, design of shaft for a machine. The material for the shaft will be selected from the list of the feasible parameters material, and the geometrical parameters like diameter of the shaft will be determined on the basis of strength equations based on stress and rigidity. So one will get different sizes of different materials chosen. So obviously there, when we are going for this selection of different metals, the different diameter will be in we get. So such all design are nothing but an adequate design, but these are the many possible solutions, but we want a single solution. Out of that, how we can select? That is an optimum design. So optimum design is selection of material and the values, independent geometrical parameters, and with explicit objective of either minimizing most significant undesirable parameters or effects and maximizing most significant functional requirement, while making certain that the mechanical elements satisfies functional requirement and other undesirable effects are kept within tolerable limits. For example, you can say design a shaft for a machine with minimum weight criteria for that particular application. Then there will be a single solution out of various options available. Such design is called an optimum design. So again, the classification of parameters like specified parameters, limited parameters, and unspecified and unlimited parameters. So specified are the known parameters. Limited parameters are the it's a value, it's a range is given. But in unspecified and unlimited parameters, they are neither specified nor the limited parameters.